Okay, Trig 4 is Pythagorean identity. Okay, so we need to remember the Pythagorean theorem. Can somebody raise their hand and tell me what the Pythagorean theorem is? Go for it. Very good. A squared plus B squared equals C squared. C is the hypotenuse. A and B are the legs. Okay. So in our coordinate plane, what do the x values represent in our unit circle? X values represent what? We just did it on the unit circle. Cosine. Very good. And then Ryan, what would the y values represent then? Sine. Yes. Thank you, Lucy. The y values represent the sine. Okay. A and B are the x and the y. So using the Pythagorean theorem to derive the Pythagorean identity, instead of A and B, you're going to have cosine and sine. So cosine of theta squared plus sine of theta is a Greek letter. Yes, it represents the angle. It's like an x value, a variable, okay, but they usually use it for degrees. Equals the radius, or in this case the hypotenuse or the radius, are 1. Does that make sense? Okay, but they don't leave it like this. Okay, what they write it as, instead of saying sine of theta squared, okay, if you leave it like that, some people might try and square their angle, and that's not what we're trying to square. We're trying to square the sine of it. So they rewrite it like sine. They put the squared on the sine and then the degree. So you don't square the degree. So it was like 30 degrees. They don't want you to square it and make it 900 degrees. And then they'll do the same thing with cosine. Cosine squared theta. And what's 1 squared, class? 1. So this is our Pythagorean identity. Okay. We can use this to find cosine and sine of other angles, other than 30, 60, and 45 reference angles. Now tangent we've already kind of talked about. Okay, so for this, okay, Olivia, what does tangent represent? What would be the tangent of this? If A, B, and 1, what would the tangent be? Okay, tangent in SOHCAHTOA is what? What is the tangent? What does the O represent? Opposite. So what's the opposite of this angle? Opposite angle, what is this? B. What is the adjacent? A. So tangent theta would be B over A. What does the A represent? We just talked about this. The A or the X value represents what? our cosine, right? And then what does the b values, the y values represent in our unit circle? The sine. Any questions over that? So we're going to replace the a and the b. The b value is going to be sine, so tangent equals sine of theta over the cosine of theta. We've already given you this ratio, okay? But this is why it works. Any questions over that? Scrolling down now. We're going to verify the Pythagorean identity with the given values of theta. So we're going to start by graphing it and finding the sine and the cosine of 30 degrees. We should be very proficient at this by this point. So we've drawn our triangle. Our reference angle is 30 degrees. Isabel, what goes here for our ratios? 1. Carissa, what goes here then? And Stephen, what goes here? Sorry, what goes here? 2. Okay, so that is our wonderful ratios for a 30, 60, 90 right triangle. Okay, we're going to find the sine now, which is opposite over hypotenuse, and then the cosine, which is adjacent over hypotenuse. So the sine of 30, okay, Noah M., what's the sine of 30 then? Over the hypotenuse is 2. Any questions on how I got that? Okay. Then the cosine of 30. What is it, Tyler? Square root of 3, the adjacent, over the hypotenuse. Square root of 3 over 2. Any questions over that? Okay, so now we're going to plug it into the sine squared theta plus the cosine squared theta equals 1. Okay. So we're going to have 1/2. We're going to square it plus the square root of 3 over 2 squared, and it equals 1. Any questions over that? It's not mine. Yes. Okay, what's 1/2 times 1/2? 1/2 times 1/2 is 1 over 4, so 1/4. The square root of 3 over 2, so the square root of 3 over 2 times the square root of 3 over 2. Square root of 3 times the square root of 3 is the square root of 9. 2 times 2 is 4. The square root of 9 is 3, so 3 over 4. So then 1/4 plus 3/4 equals 4 over 4. And does 4 over 4 equal 1? Yes, so it works. Does that make sense? Yes. It's always going to equal 1. We're just proving that to you. Okay, so now we're going to do the next one, same thing. Can someone raise their hand and tell me what pi over 4 is in degrees? Go for it.
No, 45.
There you go, 45. Okay? So pi over 4 equals 45 degrees. If you don't know that, then you need to set up the proportion. Okay? But you should, by now memorize that. X over 360 equals the radians pi over 4 divided by 2 pi. And cross multiply and solve. Okay, so we're going to draw that triangle now. We're still in the first quadrant, so everything's positive here. My reference angle is 45 degrees. Okay, Samantha, what goes here for 45, 45? What goes here? What goes here? Very good. Those are my ratios. So the cosine of pi over 4 equals, what is it, class? 1 over square root 2, very good. And then the sine of pi over 4, class? 1 over square root 2. Yes? We don't need to. We can leave it like this. We don't need to rationalize the denominators here. Okay, so we're going to plug it back into our sine squared theta plus cosine squared theta equals 1. So the sine is 1 over square root 2. So 1 over square root 2 squared plus the cosine, which is 1 over square root of 2 as well. And then it equals 1. Always equals 1. So 1 over the square root of 2 times 1 over the square root of 2 equals 1 over the square root of 4. Class, what's the square root of 4? 2. So 1 over 2. Please write down that work. You don't have to show that work every time, but in your notes you need to. So remember where that came from. That means 1 over square root of 2 squared again is going to be the same thing. Yes, and hopefully you know that a half plus a half equals a whole. So that's going to give you 2 over 2 equals 1. Does 2 over 2 equal 1? Yes, good. You've done something wrong, go back and fix it. It's always going to equal 1 unless you've done something wrong. Then go back. You've either found the sine and cosine incorrectly, okay, or you add and subtracted incorrectly. No. Because sine and cosine are never undefined. Okay, on the back. Here's how you're actually going to apply this. So if they give you a sign, like 0.766, and they give you a quadrant, which is in between 0 and pi over 2, you can use the Pythagorean identity to find the cosine of that angle. So we'll start by the terminal side of the angle lies in which quadrant? What's in between 0 and pi over 2? So let's draw our graph. Since we're in radians, this is 0. Let's draw in our radians. This is pi over 2. What's this right here, class? What is it, class? Pi, right? The whole thing is 2 pi's. Anyone know this one? Oh, good. Please write this down. Please label all the stuff, because you're going to forget this when you go home. So if the angle is in between 0 and pi over 2, where is it? It's in quadrant 1. So this is 1, this is 2, this is 3, this is 4. Okay, so the terminal side of the angle lies in quadrant 1. because it's in between 0 and pi over 2. And that's our quadrant 1. Any questions over that? Okay. And cosine in this quadrant, these are all students, take calculus. In quadrant 1, is cosine positive or negative? Positive. Okay, so you want to make sure your answer is going to be positive. Okay, so, no, it's next week. So I'm sure we're going to get a little thing right now. So this is our sine. We're going to plug it into, oopsie, sine squared theta plus cosine squared theta equals 1. I'm sorry? No. Okay, so sine, we're going to plug that in for sine, which is 0.766, that squared, plus the cosine squared theta equals 1. This is where we're going to want our calculators. Okay, so you want to square this. Okay. I'm going to write it down here. Everyone write it down, please. So that's going to give me 0.586, if you round well. Okay? Plus the cosine squared theta equals 1. Then you're going to subtract this from both sides. Don't do anything on your calculator yet. I'll explain what to do. Okay, since you're wanting this to be negative, you have a plus or minus sign on your wonderful calculator. So hit the plus or minus sign.
Teachers, students, excuse the interruptions, but our bells were off today. They were on the rally schedule, so please disregard that last bell. The rest of the bells will ring at the proper time. Thank you. Have a great day.
Okay, so you're going to make that number negative, so negative 5.586756, and then you're going to add 1 to it. This is negative, right? Negative 0.568. Okay? Then you're going to get the cosine squared theta equals 0.4132. Add 1 to it. Yes. I'm trying to make it so you're not rounding 15 times, because that can throw off your calculations. So if you can keep that number in there, it'll work, but it might not be exactly on the test.
Okay.
You might be off a couple because of the rounding issue. Okay? Okay, then you're going to square root both sides.
Where'd you get 4 when we do that?
1 minus this. You square root that, and that just gives the cosine of theta equals, you take your calculator, you square root it. Where's my square root button? And I get 0.6 428. Everyone able to do this on their calculator? Okay, you need to be able to do this on your calculator. So, and I've already said that it's positive, so it's positive 0.06428. Now, it's very important that you make sure that you've checked the sign, because it's always going to turn out positive. Because you're going to take a square root, and the square root has to be a positive number, right? You can't take the square root of a negative number and have a negative. So you need to check the sign. Okay? Any questions over that? Okay, next one. So that same thing, the cosine now, they're giving you the cosine instead of the sine, is negative 0.906. Now we're in between pi and 3 pi over 2. So find pi and 3 pi over 2. And that's this quadrant, quadrant 3. Does that make sense? In quadrant 3, all students take calculus. The tangent is positive, so the sign is negative. So your answer is going to be negative. Any questions over that? We're all good? Okay, we're going to use that same formula, the sine squared theta plus cosine squared theta. We're going to use the same formula. We're plugging this in for cosine now. So we have sine squared theta plus, make sure you put this in parentheses, negative 0.906 squared equals 1. Okay, so some of your calculators are not as smart as we are. Okay? If you don't have parentheses around this, sometimes it'll square it and keep it negative. Okay? You don't want that. When you square something, it becomes positive. So that's why you want to write this in parentheses and then square it. You already have the cosine? You can do the math, yes, I get what you're talking about. So we're going to do 0.906. We're going to square it. And I'm going to get sine squared theta plus 0.8208 equals 1. Then you're going to subtract that from both sides. So you get sine squared theta equals and I have 0.1792. Yes. Yes. I would do, I think on your homework it's 4. They're asking you to round to the 4th decimal. And especially if you're rounding things, you kind of want to have it to 1 more than what you should. Just help you round. I'm doing everything on my calculator, so I don't have to round anything. So I have the sine of theta equals 0.423. 3. I'm going to have the 3 because I started with 3. I'm going to end with 3. I had 4 here, but... Okay, so this is... But make sure you remember, it's negative 0.423. because it's in. I can do 4, that's fine. Either way, it's fine. Any questions over that? We're all good? Okay, next one. Okay, you guys do the next one on your own. E on your own. Actually, let's do E together and then you do F on your own. C. Okay. What would happen if the cosine to the cosine if you changed 0 to pi over 2 to pi over 2 to pi in example C, and then explain that. So we go back up. In example C, in this quadrant, quadrant 1, all of them were positive, so cosine was positive. If I changed it to quadrant 2, pi over 2 to pi, what? Very good. This sine would be positive, but cosine would be negative. Okay, so we would say, let's make this sound better. The cosine of theta would become negative because in quadrant 2, cosine is negative. Any questions over that? We're all good? Okay, now you ask. Okay, Krista, what would you get?
I put it was the same because sine is negative in both quadrant 3 and 4.
Very good. So this is in quadrant 3. It changed to quadrant 4, and like she said, sine is still negative in quadrant 3 and 4. Yes? Okay, just hold on to it.
But then cosine is positive, right?
Yes, but we're just worried about the sine.
But isn't like sine equals cosine?
No.
That's what we put in for cosine.
We're good?
Yeah.
Okay. So the sine would stay negative. Because sine is negative in quadrant 3 and 4. Any questions over that? We're all good? Okay. Next, now we find tangent. So what is the approximate value of tangent in example C? So let's remember that tangent of theta equals the sine of theta over the cosine of theta. So we're going to go back to an example C. We had the sine, which was 0.766. 0.766. We're going to divide that by the cosine, which we found to be 0.6428. We can have it. We're going to use our wonderful calculators to find that. I got the tangent of theta equals 1.1917. Okay. Any questions over that? They're both positive. If they're both the same on the top and bottom. Mm-hmm. Oh, yes. But 6, right? 6 can go into 7 one time, right? Okay. Everyone does each now for me. Make sure you're putting the sign on top. Isabel, what did you get?
0.4.
Do we agree, class? No. What do we think it is? Dylan, what do you think? 0.00. I don't think so. 0.4. Do we agree, class?
I got 4.4669. You guys do 4.2 or 4.233. 1.3. That's why we get it.
I have this on the board. What did you get? 466?
Yeah.
Okay.
4.669.
Which would round to 4.67, right? Which is fine. Okay. But if you use the whole number, like you said, the 4233 divided by 0.906, and a negative divided by negative will make that positive. Okay, your homework is that worksheet and the review for your test. Any questions over that? Oh yes, pass those forward.
What?
Your quiz, your unit circle.